let's talk about a concept called isomorphism. So isomorphism is about two graphs g1 comma g2, let's say, and we say that two graphs are isomorphic if they have same adjacency. Adjacency in the means connectivity. Example, let's say take two graphs like this a b c d, and let's draw a cycle like this. Then g2 1 2 3 4. So 1 to 4, 4 to 2, 2 to 3, 3 to 1. So if you see these two graphs, apart from labels, okay, don't worry about labels. Structure wise, they have same structure. Here, there are four vertices, you have four vertices, and every vertex is connected to two other nodes. Here also every vertex is connected to other two nodes, and not more, apart from that, every vertex, example, if you have a vertex A, in the same way we have vertex 1. That means whatever vertex A is doing, example, vertex A is adjacent to two vertices, right? In the same way this vertex also adjacent to two vertices. Okay, so then we say that these two graphs are isomorphic. So to say two graphs are isomorphic, the adjacency, so let me say the adjacency between these two should be same, like whatever the adjacency they have, this graph also should have same adjacency. Adjacency means the connections, like whatever the connection this graph has, same connections this graph should have. So informally I can say like this graph somehow by adjusting the edges, like example, if you redraw this graph without losing the relationships, and if you get this kind of structure, then we say two graphs are isomorphic. Example, what I do is I redraw the graph. 1 to 4 I write first, then 4 to 2 I write, then 2 to 3 I write. So I am not losing any adjacency. So 3 to 1 if I draw, then same graph I got, right? So then these two graphs are called isomorphic. So this is informal idea about isomorphism. So far whatever I told you, it is informal idea about isomorphism. Then what is formal definition of isomorphism? We'll see. Two graphs are G1 and G2, let's say, with vertices V1 E1, V2 E2 are isomorphic if there is bijection. You know what is bijection, right? One-to-one correspondence. Usually, bijection is nothing but, example, there are two sets like 1 2 3 ABC. Bijection is nothing but this kind of mapping. So you know that. So if you don't know, then please go through functions lecture first. After that you come to this this lecture. In functions I taught what is bijection. Now there should be a bijection from one set to another set, and what is the domain and codomain? From vertices of G1 to vertices of G2. So we have taken two graphs, right? Every graph has vertex set. Then vertices of graph 1 and vertices of graph 2, if I take as domain and codomain, let's say V1, V2, there should be a one-to-one function. And that function should satisfy this condition. What is that? For all vertices u and v in G1, whatever the two vertices you take in G1 graph, then if that u comma v is an edge in graph number 1, then that should happen if and only if f of u, f of v belongs to belongs to edge set of graph 2. That means, example, 1 2 3 are vertices of, let's say, graph 1, ABC are vertices of graph 2. Then example, in your graph G1, I am showing for just example, there is an edge from 1 to 2. Okay, then this is, let's say, graph G2. Now what is, according to this mapping, what is f of 1? F of 1 is A, f of 2 is B. Then according to the definition, if really two graphs are isomorphic, f of 1 and f of 2 should belongs to edge set of the graph 2. That means f of 1, let's say here A, f of 2 is B, between A comma B there should be an edge. Similarly, if there is, the if and only if means, if this is true, this is true. If this is false, this should be false. That means if there is no edge between u comma v in graph number 1, then in G2 also there should not be an edge. That is what if and only if. So that means if there is no edge between 1 comma 2, then A comma B also should not have an edge. What is the significance of A and B here? Where A is the image of 1, B is the image of 2. But how to decide that one's image is A, two's image is B? So this definition won't say that how to calculate the images, but finally you should show such function. Okay, so you should map it. It's your responsibility. Isomorphism says that you should show such function such a way that adjacency should be preserved. Whatever I explained here is called adjacency. That means if you can show this kind of function where whenever 1 and 2 are connected, a comma b should be connected. Whenever 2 3 let's say are not connected, b comma c should not be connected. Such a function if you show, then we say that two graphs are isomorphic. Okay, but how to get that function is up to you. Okay, now what is the difficulty in this isomorphism? I will tell you why isomorphism is a difficult problem. Is, let's say you don't have any clue how to map the elements. Okay, let's see this scenario. Example, you have n vertices v1 v2 v3 so on vn in graph number 1. Okay, in graph number 2 you have u1 u2 let's say un vertices. Okay, n vertices. If number of vertices equal, then only we can have bijection. Now the question whether two graphs are isomorphic or not, if you want to know, then you should show one bijection, right? But I don't know how to map that bijection, like should I map v1 to u1 or v1 to u2, so on. So anything is possible, but there should be some bijection. Now if I use some mathematics here, there are n factorial bijections. Okay, then in the worst case what you should do is take every possible bijection and check whether that bijection is satisfying this condition. What is that condition? Preserving the adjacency. Since there are n factorial bijections, any bijection might satisfy this condition. Don't check only one bijection and don't say two graphs are isomorphic or not isomorphic. To really check whether two graphs are isomorphic or not, in the worst case, every function, bijection function you have to calculate, and for every bijection adjacency should be checked. So let me show this idea with 3 vertices. Example, if you have 3 vertices in G1, they are ABC, and in G2 you have let's say DEF. Okay, now the question whether these two graphs are isomorphic or not, then one brute force method is, like currently we don't have best methods, so we have to use only brute force method, that is like map A to D, B to E, C to F. But it may not be true, right? This may not be the ultimate idea. There are some other possibilities like mapping A to E, B to D. Even that also we have to check. That is what I am saying. So form one way of function, then check whether adjacency is preserved or not. How to check adjacency? Check edge between A to B in graph number 1. If there is a edge, then check between D comma E in G2. Then mark it like in that way. If there is edge here, there should be an edge here. And observe B comma C combination. If there is edge here, there should be edge between EF. In that way, for all the edges of graph G1, check the edges and there should be corresponding edges in G2 between the corresponding vertices. What if it won't happen? Then this bijection is wrong. It doesn't mean that two graphs are not isomorphic. Maybe another combination will work. Okay, so check one more bijection. Take one more bijection where map A to E, B to D, C to F. And again check the adjacency, like take AB and observe adjacency in G1. If AB are connected in G1, go to G2 and check between D comma E. This thing we should do for every combination of vertices. Okay, then if you somehow, so sometimes what happens is you have, let's say you calculated one bijection, then for this bijection you observe the adjacency and that adjacency is preserved. So if that adjacency is preserved, then we say that two graphs are isomorphic. But that is best case. In the worst case, what happens? Whatever the bijection you try, you might fail. Then what happens? Then in the worst case, n factorial bijections you have to evaluate. It takes lot of time. Okay, so that's why isomorphism is a difficult problem. Okay, in the worst case, lot of evaluations we should do. Now let's come to discrete mathematics. In discrete mathematics area, how we saw, see this problem is like isomorphism is. So what is isomorphism? One we learn. Second one, given two graphs, how to check that two graphs are isomorphic. That's enough. So in GATE exam, especially from discrete mathematics, they ask only one question. They give you graphs and they ask whether that graphs are isomorphic or not. Then how you check it? Already I told you. So it is very difficult to map the elements. Like if they give a graph with 10 vertices and one more graph with 10 vertices, we don't know how to map them, like which vertex to be mapped to which vertex, we don't have idea, isn't it? Then how to do it? I will tell you. There are some heuristics, otherwise some observations. If you follow that observations, we can do it. How? I will tell you. First thing, example, you have a graph with 3 vertices and there is a graph with 3 vertices, but it is like this, and second one is like this. Then definitely these two graphs are not isomorphic because you can't get mapping. Why? Because really these two are having same structure. If there is no cycle here but here there is a cycle, then how they will be same structures? No, right? Structure wise they are different. So whatever you do this graph, like whatever the way you adjust, you never get it back. That means this cycle will decide that these two graphs are not isomorphic. So isomorphic means the structure of the graph should be same. Understand? So in that way, easily we can check whether two graphs are isomorphic or not. For that, there are some important properties. I will explain them.